Students, shooting with guns is not that easy. We see in films how heroes shoot the villains and bad people so easily, but in real life, shooting can be troublesome. People have damaged their shoulders because of the wrong methods of the shooting. So, professional shooters who play in sport competitions like in Olympics take lot of precautions and care to avoid damage due to shooting. Today, one of our topic will be related to this particular phenomenon. So, let us continue with the lesson Force and Laws of Motion, which is chapter number 9 of our syllabus. And today we will be dealing with third law of motion and conservation of momentum. This is part number 3 of the lesson. In the last session we had studied about inertia and mass, Newton's second law of motion, and then we studied about mathematical formulation related to Newton's second law of motion. And today we will be dealing with third law of motion initially. So what is third law of motion? Third law of motion states that when one object exerts a force on another object, the second object instantaneously exerts a force back on the first. For example, you are pushing a wall, then wall will also push you in opposite direction. This is what we call as third law of motion. In simple language, we can say there is equal and opposite reaction to every action. Okay. These two forces are always equal in magnitude but opposite in direction. This is one example which I was talking about at the starting point of the video. When gun is fired, it exerts a forward force on the bullet, and in return bullet exerts an equal and opposite force on the gun. This results in recoil of the gun. So when we fire with the gun, when we fire the bullet, when bullet goes forward, it exerts at the same time equal and opposite force on the gun, and so there is recoil of the gun. So while firing or while shooting, we should be very careful, especially about shoulders. We should have a proper padding on the shoulders to avoid the damage due to recoil of the gun. I will repeat. When bullet is fired, it will go in forward direction, but during firing, it will exert at that moment opposite force, which results in recoil force on the gun. So gun will also move backward. That is what we call as recoil. Let us move on to the next point. There is another example. When the sailor jumps in forward direction, the boat moves backward. I don't know how many of you have experienced this, but when you jump from the boat onto a stand, when you move forward, you exert a force on the boat in the backward direction. So you go forward while boat moves backward. This is also another example of third law of motion. So what did we study from third law of motion? For every action, there is equal and opposite reaction. And as an example, we studied about recoil of the gun. When we fire the bullet, when bullet moves forward, it applies equal and opposite force on the gun also. So gun moves backward as bullet goes forward. Now let us move on to the next topic, conservation of momentum. Momentum, as you all know, it is product of mass and velocity. Suppose there are two objects, ball A and ball B, of masses ma and mb, are traveling in the same direction along the straight line at a different velocities ua and ub. So ua is velocity of mass ma and ub is velocity of mass mb. Note that this u represent initial velocities. Now we consider that ua, that is velocity of mass ma, is greater than ub. What will happen if ua is greater than ub? You will find that after some time, first ball, that is ma, will collide on mb. So two balls collide with each other as shown in the figure. So here we have shown the collision. What will happen afterwards? The rate of change of momentum during the collision will be, what will be the rate of change of momentum? Momentum of first ball and momentum of second ball. So it will be ma va minus ua. What is va? Final velocity of ball a. And what is ua? Initial velocity of mass ma. So final velocity minus initial velocity divided by time into mass will give you the force or rate of change of momentum. We all know from second law of motion that rate of change of momentum is nothing but the force. So this is rate of change of momentum for mass ma. Now let us see what happens for mass mb. So rate of change of momentum for ball b will be, it will be similar, simply we replace a with b. So mb into vb minus ub upon t. Now vb, you might be knowing, vb is the final velocity of ball b and ub is the initial velocity. We always calculate change in velocity by subtracting initial velocity from final velocity. So vb minus ub. Now let us simplify this relation. According to third law of motion, the force FAB exerted by ball A on ball B and the force FBA exerted by ball B on ball A must be equal and opposite. So I must say that FAB should be equal to minus FBA because they are equal and opposite as per third law of motion. Now we will use this knowledge in earlier two relation, that is MAVA minus UA upon T will be equal to MB VB minus UB upon T with a minus sign. Why? Because it is opposite. Now if we simplify this relation, we will get a different relation altogether. So let us move on these two equations first at the upper side of the page. So I have moved it. Now let us make place for another equation. So if I simplify this equation, if I take initial velocities, that is UA and UB on left hand side and VA and VB on right hand side, I will get MAUA plus MBUB is equal to MAVA plus MBVB. What happened to T? It got cancelled because it is same, it is a like term, so it got cancelled. So what remained with us was MAUA plus MBUB is equal to MAVA plus MBVB. This is nothing but initial momentum and this is final momentum. So they both are same. Thus we observe that sum of momenta of the two objects before collision is equal to sum of momenta after collision, provided there is no external unbalanced force. This is law of conservation of momentum. Students, let us see the derivation one more time. What we start with while proving conservation of momentum is, we start with rate of change of momentum during collision for mass MA and for mass MB. So rate of change of momentum during collision for mass A will be MA VA minus UA upon T. Why VA minus UA? Because we always subtract initial velocity from final velocity, and this VA minus UA upon T is nothing but acceleration. Change in velocity upon time is nothing but acceleration, and acceleration into mass is nothing but force or rate of change of momentum. So this is for mass MA. Then this relation MB VB minus UB upon T is for ball B. Then what do? We use third law of motion. Third law of motion states that FAB is equal to minus FBA. then we use the earlier two relation. Ma Va minus U upon T is equal to minus Mb Vb minus Ub upon T. Why this minus sign? Because the forces are equal and opposite. Now what do? We simplify this relation. We cancel the like terms. This one T, they are like terms, so they cancel out, and what remains with us is MAUA plus MBUB is equal to MAVA plus MBVB. How did we get this relation? We moved initial velocities on left hand side and final velocities on right hand side, and thus we got this relation. This is nothing but initial momentum and this one is final momentum. So we find that initial momentum is equal to final momentum. So before collision momenta and after collision momenta, they are same. This is what we call as law of conservation of momentum. Students, I hope you understood today's topic. If you have any doubts, feel free to ask. But before closing this session, let us see what you can try out at home. So there are a few questions that you can try. State Newton's third law of motion. Here you have to write only statement. Then in second question, explain with example Newton's third law of motion. You have to give examples to explain Newton's third law of motion. And the last question is derive relation for conservation of momentum. This is what we studied in the last topic. So you have to answer them. We have discussed all these topics, so you will find it easier to answer them. Okay. Again, I repeat, if you have any doubt, feel free to ask. You can put your comments in the comment box. Okay. In the next session, we will be dealing with another topics from the chapter. So see you in next session. Until then, take care. Bye bye.